JMath.
In this video, we will discuss when an identity is undefined. Now, there's only two cases where that happens, and that is if you divide by a zero. So that rule has been present from the moment you started learning about dividing in the primary school. You can never divide by a zero. So whenever they give you a question like this and they ask, when is this undefined? If there is a fraction, you must just write that fraction cannot be equal to zero, and then you do the general solution for that equation that you set up. The other case is whenever you have a tan, just write down that tan function's asymptote. And the standard asymptote for tan is always 90 plus k 180. So unless it is tan 2 theta or tan theta minus 5 in a bracket or something, the answer will always be 90 plus k 180. So let's do a sum like this, and I'll show you exactly what you need to write down to get full marks. For which values of theta is the identity undefined? Okay, so they're not asking me to prove that left hand is equal to right hand side. They are asking me just for the undefined. So when starting a question like this, I like to just give myself some heading. So I can see there's a tan and there are fractions. So I'm going to do denominators and asymptotes. So I would start off by saying denominators equal to 0. And the only denominator in that sum is then just sine 2 theta. So I'm just going to say sine 2 theta must be equal to 0. So remember, they're asking me when is it undefined. So then I can say it's equal to 0. If they ask me when the identity is valid, then I would say not equal to 0, like this. But in this case, they ask me when is it undefined, so I don't need that. So now I can just do general solution for that question. And remember, if it's equal to 0 or 1, I can just follow the graph to get the answer. So in this case, my sine graph would be 0 at 0 degrees and at 180 degrees. So the answer to this question is just 2 theta is equal to 0 degrees plus k 360. So therefore theta is equal to 0 plus k 180. Now that's only the one quadrant. So that was quadrant 1. And then if I say quadrant 2, I must say, okay, but 2 theta can also equal to 180 degrees. So you can follow the quadrant and the reference angle if you want to, or you can just draw the graph and see where it is actually equal to 0. So in this case, I must just add a plus k 360, and the final answer is then 90 plus k 180. Remember, I must just put that somewhere. So I now covered the denominators. Now I must just cover the asymptote. So I'm just going to write the word asymptote. So for any asymptote, I can then just write theta is equal to 90 plus k 180. Perfect. That is the answer. So it's weird questions, but as long as you just cover every denominator and every tan that is in the sum. So if I look at the second example, I can see there are tans in the sum and there are two denominators. So I need to cover both of them. So I'm just going to say 1 minus tan theta must be equal to 0, and therefore 1 is equal to tan theta. If you remember your special angles, tan of 45 is equal to 1. So in this case, I can do the full general solution. You are welcome to, or you can just say theta is equal to 45 degrees plus k 180 because it is tan. Okay, so there are a few of these ones that you can just remember and study off by heart and then write it down. You don't need to show working or anything. This is one of those cases. So I know it's also equal to 1 at 225, but because it's tan, I just need to write down one quadrant. So there I covered the one denominator. So now I must just also cover the other denominator and say this is also undefined if cos 2 theta is equal to 0. Now in this case, I need to remember the cos graph, and the cos graph says it's 0 at 90 and 270 degrees. So now I'm just going to write that for them, and that would be the answer to the question. So 2 theta is equal to 90 plus k 360, therefore theta is equal to 45 plus k 180, okay, and then or 2 theta is equal to 270 plus k 360, and that gives me 135 plus k 180. Okay, perfect. So that was the denominators. There is still a tan in that sum, so I must just then also say asymptote. And whenever I see a tan, I can just immediately write theta is equal to 90 plus k 180. There we go. So as long as they see the three answers, I will get my mark. So there's the one, there's the other one, and then this is another unique one. So because the 45 was already there, I'm not going to get marks for both of them, but those are the answers they want to see. In the last example in this case, so I have two denominators and a tan. So I'm again just going to do my heading. So if I start with the first denominator, I can just say cos theta minus sine theta must be equal to 0. If I move the sine over, I can just divide both sides by cos, and I'll get 1 is equal to tan theta. And as we saw earlier, theta is equal to 45 degrees plus k 180. So remember, you can do the full general solution, or you can just memorize this one. Okay, the other one, cos theta plus sine theta equals to 0. If I move the cos over and I divide by cos, in this case, I will get tan theta is equal to minus 1. And that one would then be 180 minus 45. So theta is equal to 135 plus k 180. Perfect. There I covered the denominators. So now for asymptotes, I can then just say there's a tan 2 theta. So in this case, for my asymptote, I must say 2 theta is equal to 90 plus k 180. So in this case, the asymptote will be at theta equals 45 plus k 90, because I had to divide both by 2. And those values will tell me where will this identity be undefined. So at 45 plus k 180, 135 plus k 180, and then 45 plus k 90. Whenever you find this question of where is the identity undefined, remember asymptotes and denominator is equal to 0. And then they won't be able to catch you out.
If this video helped you, please like and subscribe.
JMath.